Hello everyone, welcome to my YouTube channel Chemistry Lovers. In this video I have shown you the tautomerism. In this video I have only discussed the introduction of it. I will bring a next video regarding this tautomerism in upcoming week, and in that video I will cover the next portion. Okay, so here you can see I have written tautomerism, which is a phenomena where a molecule exists in more than one configurations in a particular equilibrium. You can see that if a given molecule is given to you, then this molecule exists in either keto form or enol form, and there is a equilibrium exists in between these two configurations. Generally, keto form is comparatively much more stable than enol form. The reason I will be told you a few minutes later. Okay, so up to this you can understand that the keto form is much more stabilized than enol form. Thus the population of keto is higher than enol. You can see 70% is keto and 30% is enol. So here I have written some basic difference between these two configurations, which are these. That is, there are three different bonds present in this keto configuration of the molecule, which are this: H sigma bond C, C sigma bond C, and C pi bond O. And in enol form, these three different bonds are given below. And the keto form is much more stabilized than enol form due to there is a difference in bond energy between them, which is 15 kilocalorie per mole. Okay, I will not return the bond energy, so you can calculate it easily. So main reason is that there is a difference of bond energy present between this keto and enol form, which is 15 kilocalorie per mole. That is, keto form is much more stabilized than enol in bond energy. Thus the keto form is generally much more stabilized and its corresponding population is higher. I have written here some example so which you can understand the phenomena easily. So this is like acetaldehyde. Here it is a keto configuration, while a carbonyl group present here, and with respect to alpha position there is a carbon atom present, and in the carbon atom 3 hydrogen atom present. So there like I will see a CH bond present, CC and CO. So here you can see these bonds are present, and here this is its corresponding enol form, and I have written here the three different bonds. So up to this you can understand that for acetaldehyde, keto is very much stabilized than enol, thus its configuration and its regarding population is higher. And another example I have shown here, this is also an example of aldehyde. This here also alpha position there is one hydrogen atom present, but in this molecule keto is not so much stable as like enol. That is, in this case enol configuration is much more stabilized than keto, which is not usually characteristics for tautomerism, right? We know that keto is much more stable than enol form, but here this will not follow for only this molecule, because here you can see when this molecule exists in enol form, so there will be a possibility of extended conjugation which take place among the hydroxyl group pi bonded two carbon atoms and the carbon and adjacent phenyl group, through which these three groups take part in resonance very easily and increases the stability of the overall system much more. So here you can see the extended conjugation take place, where the oxygen through its lone pair using plus R effect donates its electron toward the pi bonded carbon atom, and this it will further undergo through resonance into the phenyl ring, and in this way the overall system gets stabilized much more. Thus the given molecule exists in enol form rather than keto form. So this is an exceptional case you can see where enol is much more stabilized than keto, as well as its corresponding population will also higher than keto. Another example I will show here. You guys must know this molecule, right? This is known as acetylacetonato, ACAC. Short form is ACAC. So here we'll also observe that enol is much more stabilized than keto form. So for the above molecule and this molecule, these two are exceptional cases where the enol configuration is comparatively stable and its population is higher than keto. Same reason the enol form is stable due to first extended conjugation take place among these three groups. Intramolecular hydrogen bonding, you can see here that the hydroxylic hydrogen atom undergo intermolecular hydrogen bonding with the carbonyl oxygen. And quasi-aromaticity, another new term I have introduced here, which is that these 5 atoms though doesn't fulfill all the conditions for being an aromatic system, but they seems to be an aromatic system. Let me explain you clearly. Here you can see in the structure the OH group pi bonded 2 carbon atoms and the carbonyl one. So here if you count those atoms 1 2 3 4 5, these all are being sp2 hybridized containing an anhybrid 2p on them, undergo parallel overlapping and containing 2 4 6 10 pi electrons, 2 6 10 pi electrons among them, and it will also cyclic and planar. So these conditions though satisfy aromatic system, but here this hydrogen atom doesn't be an sp2 hybridized, so it can't contain any anhybrid 2p on it. So except this hydrogen atom, all the atoms possess or represent the aromatic conditions, but not this hydrogen one. So it does not fulfill the conditions of aromatic only for this hydrogen atom. So for this reason I have introduced the term quasi-aromaticity, which is it seems to be aromatic but not aromatic actually at all. Like it behaves like an aromatic system, but not in actual it is not an aromatic system at all. It behaves like an aromatic because here you can see that this is a cyclic system. You should know the condition for the aromatic system, like it will be cyclic, it will be planar, all the ring atoms possess an anhybrid 2p over them, parallel conjugation should be take place between them containing 2 6 10 pi electrons. So except hydrogen atoms, all these are cyclic and form a planar system, anhybrid 2p orbital present on over them, and parallel conjugation also take place except this hydrogen. So this is the main obstacle for being which doesn't represent this aromatic character. So here also the enol form is much more stabilized and exists mostly in this case. So if you have any doubts regarding this theory, then please comment me, or I will definitely try to sort out your doubts, and I will also bring a next video regarding this topic. Then up to this, thank you.